several parametric tests like z-test or t-test, z-test or t-test. So ANOVA actually is is similar to t-test. The purpose is to compare the 2 or 3 or several groups. Actually, we can we can use t-test to reflect ANOVA. But as I said before, if you have several groups, more than 2, you have 3 groups, for example. So if you do t-test to compare each 2 groups, you have to perform 3 t-tests. Or if you have 4 or 5 different groups to compare, you have to perform much more number of t-tests. So ANOVA will reflect t-tests to compare at the same time different groups. So you will obtain the faster result compared to t-test. Okay, so we continue. In the example I gave you before, so we have 12 or 10, yeah. Actually, at the beginnings, they will have more than 12 chickens for each kind of feed. So remember, we have 3 kinds of feed: feed A, feed B, and feed C. So at the end, they design the experiment, and the number of chickens for each feed type will be more than 12 or 12. However, because the experiment lasts for 1 year, so for a long times, and because of different environmental factors or genetic variations, so some chicken die because weather, the temperature, humidity, or disease. Some chicken die. So at the end, the result they record is number of the 10, and 12 chickens lay the eggs in each type of feed. So you have 10 chicken for feed A, 10 chicken for feed B, and 12 chicken for feed C. Yeah, this one, the table here. You have 10 chicken for feed A, 10 chicken for feed B, and 10 chicken for feed C. So from that, you can calculate the average eggs given by the feed type A, feed type B, and feed type C. So there are 3 possibilities. You could have the big effect of control factors. And in this example, the control factor is the feed type. And you have small effect of uncontrolled factors. The second possibility is that you have small effect of control factors and big effect of uncontrolled factors. And the last case is the equal effect of control and uncontrolled factors. So in the experiments, our purpose is to study the different type of feed, which feed will give the best the number of eggs, the highest eggs. What can you say about the effect of feed? We have to investigate it. So before answer the question about the action of feed, we have to make an hypothesis. And as you saw before, we have the H0 and H1. In H0, it means that all level of treatment belong to the same statistic populations. It means that the 3 feed has the same effect on the number of eggs. Okay. And the alternative H1 hypothesis is that preface the doesn't have, three feet don't have the same effect on the number of eggs laid. And we will go to find which feet will have the highest number of eggs, will have the highest result. We hope we will accept the H1 in this case. So the requirement for ANOVA and for t-test and for z-test as well is the all observation, the distribution of observations will follow the normal distributions. Okay, so you have to check the data first if the data follow the normal distribution. Okay, if it's follow, you can apply t-test, z-test, or ANOVA. Otherwise, we will have another test. Okay, so there are different parameters that we need to calculate in order to perform the ANOVA. First is the big mean. What is the big mean here? You see the equations. So big mean equal the mean, small mean divided by n. Small mean here, it means that the mean of x feet. So you have mean A, mean B, and mean C. And the big mean is the mean of mean A, mean B, and mean C. Okay, so you have a big mean, you have small mean. The next one is to calculate the variance of the totals. The variance of totals, you see the equation here is equal to the sum of x. Small x here is the value of the observation. So you have the observations here. You have the 32 value here. So small x will be this 32 value. Minus the big mean. So you calculate big mean array root square. Divide by n minus 1. N minus 1, n is total observations. In this case, you have 32 observations, right? So the big N will be 32 minus 1 is 31. Next. How to know the fit variance? If we only concentrate on the fit, we would like only to study the effect of fit on the number of eggs. We have to remove the genetic variation. In this case, we consider that all the chicken have the same genetic variance. All the chicken have the same genetic backgrounds. So there's no variation between the genetic of chickens. In this case, by assuming that we can study the effect of level fit on the number of eggs. If there's variation in genetics of chickens, so we will study two different parameters at the same time. At the end, you get the result, but you cannot conclude the result is because of the feed level or because of the chicken genetic variation, right? Remember when you do an experiment, normally we will fix all the parameters except one, the parameter that you would like to study. You fix everything and you train only one. So in that case, when we give the conclusion, you said the difference or the result is because of that factors, but not because of the interaction, for example. Okay. So to know the fit variations, we must remove the genetic variations, right? We must remove the genetic variation in this case. So we imagine that all the chicken receiving the feed eggs will lay the same number of eggs. Okay, because they don't have genetic variations, so they will lay the same number of eggs. The chicken receiving the feed B will lay as well the same number of eggs, and for the feces as well. Right? So we will check the average of A compared to average of B and compared to average of C. Right? So you will have new data table like this. With the feed A, you have all the same number of eggs, feed B and feed C as well. So you have the third parameter here is variant achievement. Okay. The variant achievement will have this equation. The number equal the sum of NT. So NT here is the small n. So what is small n in A? So small n in A you have 10. Small n B you also have 10. And small n C you have 12. Okay. Multiply by small average T minus big M. So big M you calculate before already. What is MT here? Small m here. Small m here will be the M of A, M of B, and M of C. You calculate it easily, right? And divide by number of treatment levels. So in this example, you have how many number of treatment level? How many?
3.
Yeah, you have 3. And then you minus 1, so you have 2 here. So the VT here, we call it is variant achievements. Before you have the variant totals, the big VT here is variant totals. And now you have the variant achievement. Next one. How to know the genetic variation? So before we assume that there's no genetic variation, but actually it may have. Even we, if you know the, okay, you know already the term clone. So clone, we assume that all individual will be originate from one individual. So we make clone. However, in the case of chicken, even chicken come from the same mother and fathers, but they still have some variation because of some mutation, small mutation, or yeah. For example, the children come from the same mother and daughters. They will have the a little bit genetic difference. So it's the same for chickens. It must have the genetic variations. So to know the genetic variations, we must remove the treatment variations. Is the level of heat. How to do that? We take each level of treatments. In each level of treatment, the difference between the data expressed in each level of treatment, the difference between the data expressed the variation due to genetics. Okay, yeah, of course. Actually, we cannot get the same number of eggs by 10 different chickens. They must give different number of chickens, different number of eggs. It's because of the genetic variation in the chickens. Even they receive the same feed A and B and feces. You see in the data set. Each chicken gives the different number of eggs. And this genetic variation when expressed as a fourth value is error variance. How to calculate the variant of arrow you see in the equation. Okay. So now it's your turns. You using the Excel and show me the table. You have to calculate the variant totals, variant treatment, and variant of errors. And present the table like this. Okay. I'm going to show you again the data. You have data in the slide. You have the equation as well. For VT for variant of treatments. And for variant of error. Okay, you see? Open the Excel and you calculate the table. Is that clear?
Yes.
Okay. Please take your time to calculate it.
Cái thứ hai là VT nhỏ thì cái đầu tiên là 2900, degree of freedom là 2, còn variant là 1450. VE thì là 548, degree of freedom là 29, variant là 18,896. F ratio thì là 76,73. Cái nữa. Còn cái F limit thì em không biết. F limit em chưa nhìn.
Okay. Đấy là bạn Quân Hành, bạn ấy check cái bằng Excel rồi. Nào cho cô xem cái giá trị M trung bình của em bao nhiêu, M to ấy. M to
Mà to
lên.
trung bình thì là tính ra thì nó chia sẽ số lẻ là 192,6667, nhưng mà sau đấy thì em làm tròn lên 193.
Đúng rồi, nếu em làm tròn lên 193 thì nó mới giống đáp án của Excel. Còn nếu em làm
Vâng.
là 192,667, em để nguyên cái số đấy thì nó sẽ ra lẻ lẻ, nó không chính xác giống hệt cái Excel đâu. Thì cái VT của nó sẽ là 3451. VT lớn ấy, VT nhỏ là 2904 chứ không phải là 2900. Nếu làm tròn thành 193 thì nó mới là 2900. Ok. Quân Anh.
Vâng ạ, vâng, lúc đầu định là số lẻ nhưng mà số lẻ tính nó khó quá nên là đổi là số chẵn
Có
luôn.
gì
Sẽ tính xong rồi em mới check ạ. Em tính xong
có
hết tầng tay rồi mới tính check lại.
ok. Thế em chỉ cần cho vào cái file Excel ấy, xong rồi công thức nó tự động thôi mà, làm gì mà khó đâu. Ok nhá, cô bảo cái này là các bạn có thể sử dụng Excel để các bạn check kết quả. Tuy nhiên là đến khi thi thì cô sẽ cho làm số lẻ để các em phải tính, chứ các em không được áp ngay Excel và các em viết kết quả vào cho cô. Nhá. Nếu mà thế thì lại không cần phải học nữa, mà chỉ cần mang Excel ra mở ra cái là xong luôn, thì cần gì phải học nữa. Đúng không? Lúc nào mà mình học xong rồi, mình hiểu vấn đề, mình biết cách làm rồi, thì khi mà các em phân tích kết quả thí nghiệm của các em thì các em có thể dùng Excel. Ok. Lúc đấy thì không vấn đề gì nữa vì các em đã biết nó hiểu nó như nào rồi. Còn lúc mà đang tập tính thì mình phải tự tính. Nha. Các bạn khác làm nào đã biết làm chưa? Các bạn khác nói cô xem nào.
Em ra được kết quả cũng giống như của này.
Rồi, còn những bạn khác?
Em cũng thế ạ.
Vân Anh được.
Nhưng cho em hỏi, nếu mà đi thi mà mình tính lẻ thì mình có làm tròn lên không cô?
Không là làm tròn thì lại thành giống Excel rồi, thì cô lại không cần các bạn phải tính nữa, mà các bạn chỉ cần mở Excel ra, các bạn nhập số vào cái là xong luôn.
Thế
Đúng
nếu
không?
mà số lẻ lúc đi thi thì sẽ lấy bao nhiêu số sau dấu phẩy ạ?
Mình sẽ quy ước 2 hoặc 3 số sau dấu phẩy. Nếu mình quy ước là 2 thì tất cả thì cô quy ước là 2 thì tất cả các bạn đều làm là 2.
Tức là nó sẽ có ghi ở trong đề ạ cô?
Cô sẽ bảo các em là làm 2 hay 3 số sau dấu phẩy. Để cho nó không thể giống hệt kết quả của Excel được. Excel là họ làm tròn. Để đề phòng là một số bạn không làm, nhưng mà dùng Excel thì các bạn viết kết quả vào cho cô không thôi, thì như thế thì hơi thiệt thòi so với những bạn mà tự làm.
Thế thì phương án cô có chấp nhận là sai số một khoảng không cô?
Ok, đến lúc đấy rồi cô sẽ tính. Tóm lại là các bạn làm xong chưa? Có bạn nào không làm được không? Các bạn nào không biết làm không nhỉ? Thì cô hướng dẫn nào. Nhầm nó. MT là M của MA, MB và MC. 3 cái M khác nhau. Rồi, bây giờ cô sẽ show cho bạn một cái file Excel mà cô đã làm rồi nhá. Hà Nhung tắt mic đi, mic của Hà Nhung bị nhòe lắm. Bị rè rè.
Em thưa cô, cái công thức ấy ạ, ở trong cái công thức của variance of population thì cái N lớn là number of sample, thế nhưng mà đến tức là em nhớ là cái công thức của tính mean của whole population là nãy cô cho tụi em xem ạ, thì cái N lớn nó lại là định nghĩa của number of group ấy. Thế là em bị loạn mất một lúc ấy ạ.
Mean nó. Mean nó. Xem nào. Mean là population nó. Cái chỗ này là nó đã tính mean của M to thì bằng mean của M nhỏ chia cho N. Ở chỗ này là chia cho 3 thôi.
Vâng ạ, ý em là kiểu
Ok.
giữa các công thức.
Rồi.
Vâng.
Rồi. Ok, cô sẽ show cho bạn file Excel nhá. Để mình cùng làm. Bạn nào chưa làm được thì mình sẽ cùng follow. Chỗ này cô nói tiếng Việt cho các bạn dễ hiểu. Hay là tiếng Anh?
Em tiếng nào cũng được.
Okay. So first, what do we need to do? You see my Excel file, right? Oh, you see
Yes.
that? Okay. So you see you have group A, group B, and group C. Okay. You see the data, right? So when the first time when you just look the data, so you see we have 3 groups. What we need to do first?
Calculate the mean.
No, not yet. Not yet. We have to check something before. What is
Check
that?
the normal distribution.
Normal distribution.
Yeah, we have to check the normal distributions. Did you check that already or not yet? Remember, not yet. Remember, if you don't check the data follow the normal distribution or not, I will introduce you another test, and maybe you will mix between two. You will choose the wrong one. Okay. So for these data, the data is not really big difference between each other. Normally, with the normal distributions, most of the data will concentrate in the middle, and you have a few is far more different from the middle. You see 2 tails and the mean, the bell curve. So most of the data will concentrate at the middle. A few bigger or smaller data than the mean will be in the 2 tails. So by looking at these data sets, I think they belong to the normal distributions. But you have to check it. And sometimes if you remember, I said about the outlier. So if the data had outlier, you have to remove the outlier. Otherwise, it will affect the result. Okay. So you have to, I already checked it. So you see, outlier in 3 groups, A, B, C. None. It means that there's no outliers. In this case, if there's some outlier, it will show you the example I showed you 2 days ago. If there's some outlier, it will write here for you. So you come back to the data set and you remove the outlier. Okay. In this case, there's no outlier, so it's okay. Then you check for the normal distributions. So the normality, group A, yes, group B, yes, and group C, yes, as well. So they all follow the normal distributions. That is good. You can use t-test or ANOVA. Next, you can use t-test or ANOVA in this case. So you see there are 3 groups. If you use t-test, you have to make t-test for A and B, B and C, and A and C. So you do 3 t-tests. So instead of using 3 t-tests, you use ANOVA. Okay, ANOVA is similar to t-test, but it's used to apply for more than 2 groups. So you calculate the mean of treatment. So I write here small mt. You calculate the mean A, mean B, and mean C. You calculate the n. Why we calculate the n? In the the small n. In the variant of treatment, you have the small n. So and group A equal 10, group B equal 10, and group C equal 12. You calculate the mean, the big mean. Its mean is the average of all the data sets. So it's 192.667. Okay. Now you calculate the NT. This is NT. So this is the NT for the same equation in the variant of treatment. So you calculate in the upper part of the variant of treatments, you have this value. So you calculate NT multiplied by MT minus big M and square. So how to calculate this? Look at in the Excel here. You have this equal 10 multiplied by what is MT? So MT here, and minus B18. B18 is big M and square, plus against NT. NT here is 10 multiplied by MT. MT here is 201 and minus big M square. And lastly, you plus NT. NT here is 12, right? 12 multiplied by small MT is 198 and minus big M square. So you have final result is 2,903. Now, we also have to calculate the variance of treatment. So what is the upper part of the variance of totals? The upper part of variance of total is x minus big M square. Yeah, x minus big M square. So by using Excel, you have these values. X, so for x is 180 minus M. So M you have 192.667 and you square. You do exactly the same for 32 values. So you have the upper parts of the variance of totals. Then you calculate the sum. Sum of square is the 3,451.56. Okay. And next one, you have the variance of error. What is the variance of errors? It shows the genetic variations between the chickens. And you have variance of error. This is the upper part of the variance of error. This is the variance of error exactly. Sum of square. So it is XT minus MT and square. What is XT? XT is the X. The same here. X is 180, 177, 175, etc. Minus MT. And what is MT? MT here. You have 3 MT value. Okay. And then you square it. You do 32 values. So you have the sum of square variance of error. And you do sums. So it's 548. Right. Now we will have table. First is sum of square of variance of totals. You calculate before is for 3,451.56. The variance of treatment. Okay, variance treatment here. You calculate is 2,903 or 04. Yeah. It's round up to 04. And the variance of errors you calculate before here is 548. So you have sum of square here. You have degree of freedom. The degree of freedom for variance of totals. So you have 32 value minus 1 is 31. You have variant of treatment. In this case, you have 3 level of treatments. Variant 1, so it is 2. And the variant of errors equal variant of treatment, a variant of total minus variant of the degree of freedom of variant of treatment. So it's 29. So you have these second columns. Next one is variance. The variance will equal sum of square divided by degree of freedom. So you do 3 variants. Divide sum square for degree of freedom. Then is F ratios. F ratio will equal the variant of treatment divided by variant of error. So you have the final result. F ratio is 76.8. Okay. Now come back to the slide. Where am I slide? Oh. Oh yeah. Okay, so you have the table here. You have the variant F ratio. Sorry, you have F ratios equal 76.7. So how to calculate the F limit? You have to check the F table. Let me check again the F table. Okay, I will show you the F table. So someone have F table? Yes or no?
No.
Okay, you can check the F table. Here to see in the slide is F table. With the rate of error is 0.05. It is 5%. If the requirement is the rate of error is 1%, you take another one. This is F table for 5% of rate. Okay. So how can you use this? You have V1 and V2. V1 will be the degree of freedom for variant of treatment. And V2 is degree of freedom for variant totals. Okay. So variant variant of error. Variant of errors. So you have how many degree of freedom for variant of error? Now tell me. How many degree of freedom for variant of error?
29.
29, okay. And variant treatment, how many?
2.
2. So you cross 29 with 2. And what is the value? The average.
3.
Okay, it is 3.33. Okay, to see here, it is 3.33. So you compare with the F limit. You compare with the F ratios. Smaller or bigger?
F ratio is bigger than F critical.
Yeah. So F ratio is bigger than F limit. Yeah, I show you the how to. You have a degree of variance error of error, which is 29, and this is v small, vt small. So you have the variance of the degree of freedom of variance treatment is 2. So you have 3.33. So you have the F ratios 7.7 approximately 77, and the F limit is 3.33. So you have F ratios bigger than F limit. We will accept the H0 if it's bigger. If the F ratio bigger than F limit, we will accept or reject the H0.
Reject.
We reject the F0. Yeah, we reject the F0. What it mean?
It means we accept the H1.
We accept the H1, and what is the H1? What is
The fit is have different effect on the X.
on the number of X? Okay.
I think we need to find which is the best.
Okay. We go to determine which one is the best. Okay. So which fit is the best one? Calculate the difference of means between each two groups. So we have mean A minus mean B minus mean C, and mean B minus and mean B minus mean C. So we have three different means. Next, we will see if the different means belong to the range from minus 20 to plus 20, or is out of the range. If it is out of the range, we refill the hypothesis at zeros, and if it's belong to, so we accept the H0 hypothesis. So what is H0 and H1 hypothesis here? Now our purpose is to see which fit is the best. We go to see the average number of S given by fit A, fit B, and fit C. So you have MA, MB, and MC. Next, you will calculate the difference between M. You have three difference, right? And you have to calculate the SD as well. If the difference belongs to the range from minus 2 and plus 2 at least, you accept the H0s, and if it's out of the range, you refill the H0. So what is H0 here? What is the content of H0? Tell me, please. No one knows. Hello, hello. Không bạn nào biết hả? Bọc. Cũng chả nghe bạn Ngọc bạn nói cái gì. Số lần lặp lại ok, số lần lặp lại anh tính ở đây bằng bao nhiêu? Số lần lặp lại bằng bao nhiêu? Này. Các bạn hiểu vì sao lần lặp lại bằng 10 không? Có bạn nào hiểu vì sao số lần lặp lại ở đây tính bằng 10 không?
Đó, em chưa hiểu ạ.
Ok. Các em thấy là so you see a group, the feed A you have 10 chickens. Group B you have 10 chicken as well, and group C you have 12. So the repetition between three groups is not 12, because 12 only appear in group C, but not group A and group B. The repetition will be the commons, the repeat times will commons, the common repeat time between three groups. It is 10 in this case. Okay. So you have the SD equal 1.9. So you the file Excel. Okay, my Excel file. Okay, so you have SD equal root square of 2 variant of error and by number of repetitions. So you have SD equal 1.94 and 2 SD is 3.89. Okay, it is 3.89. And next, as I said, you have to see if to see which fish is the best. By cut the mean of each group, you have the mean A equal 178, mean B equal 201, and mean C 198. So just look at the mean. You think that the mean by the group B, the fit B will be the best, right? And following by fit C and fit A is the last one. However, if we check by the substitutions, we can see something different. Now we you make something like me here. So we have to check the difference between mean A, mean B, mean A, mean C, and mean B, mean C. Okay. So you have difference between mean B and mean C equal 22. Between mean A and mean C is 19, and mean B and mean C is 3. All right. To calculate the difference. So you have 3 different values. And as I said before, if the difference belong to the range from minus 2 AD to plus 2 AD, you will accept the H0. It means that there's no difference between two groups. And if the mean difference out of the range from minus 2AD to 2AD, you refill H0 and you accept the H1. It means that there is difference between two groups. Because here we going to see the difference between each two groups. So first, for the A and B, You see the mean difference between A and B is 22. So what is conclusion about A and B? They are the same or they are different?
They are different.
Okay. So A and B are different. Next, A and C.
They are different too.
They are different too. B and C.
They are not different.
They are not different. Okay. So you see, A is different with B, A is different with C, and B is the same with C. So you will divide our 3 feet into 2 groups. Group 1, you have only feet A. Group 2, you have B and C, because B and C is not different. Right? B and C are not different. A different with B and A different with C. So A belong to one group, B and C belong to another groups. Right? So now, B and C are not different. From the calculations, so what is our final conclusion? The second conclusion is B and C are not different, and A different with B, A different with C. So what is the final conclusion? Which fit is the best?
A different from B.
Yeah, A different from with B, A different with C, and B is not different with C. But my question is, which fit is the best? You have to.
Is it B and C? Because I remember that it gives lower number of eggs.
C then X of C is 198 and B is 201. And B and C are not different. B and C are the same. So what is the
Yes.
conclusion? Yeah, what is
So
the
I think that feed B and feed C is better than feed A.
Yeah. Actually, in this case, because B and C are not different, so you said B and C gives the higher X, or B and C are better than A.
Yes.
Okay.
Yes.
Yes, that is the final conclusion of this exercise.
Yes.
You are clear all? Clear?
Yes.
Or any question? Any more questions? So I show you the ANOVAs. Maybe you know already. So instead of doing by hand, by using Excel, we have the ANOVA integrate into Excel. So you go into data, you go to data analysis, and you choose ANOVA single factors. Okay, click OK. Input range, you select the range. Groups by columns. Yeah, because here you groups the data by columns. The label in the first row, you click in this because you put the label ABC in the first row, and then you select the input range. Okay. So you have the final result here. So you have ANOVA table. Okay, you have ANOVA tables. You can show you group A, group B, group C, counts is n, number of observations, sum, average, and variance. The ANOVA table I asked you to show me, we just do together. So we had the variant totals, variant of treatments and variant of errors. It helps you to calculate the sum of square, degree of freedoms, variance, F ratios, and F limit or F crit. F crit from tables. F ratio is divided by variance treatment. Is the result from variance treatment divided by variance error. So you have this. You have this, the F ratio. You see, it's approximately the same our result. It's only different because we take the number after the commas. Here they round up and we take number, small number after the comma, so it gives a little bit difference compared to our result. That's a little bit different.
Teacher, can I ask again, like, how can we determine if the group is different or not different?
Group is different or not different with each other?
Yes.
Well, I just told you before.
Yeah, but this just so we just need to see the difference between the mean.
We see the difference between the mean and then we compare with SD.
So if it's larger than SD, then this is different.
Okay, so we set a range from 2 SD to minus 2, sorry, from minus 2 SD and plus 2 SD. Oh, okay, I cannot write. How can you write it here? It's minus 2 SD. Yeah, and plus 2 SD. So you calculate 2 eddies and then the range from plus and minus 2 eddies. If the different means belong in this region, it means that the two groups are the same. If they out of the range in two sides, you say that they are different. Okay, and in this case we have the range from minus 3.89 and 3.89. We compare the mean, 22 bigger, 22 is out of the range. So we say that B and A difference is the same. 90 and 19 is bigger than 2 eddies. So B and C are different. The B and C, the different mean is 3 and they belong to the range. It means that B and C are not different. So they are the same. The action of fit B and fit C are the same to the number of X. Okay, so by doing that, you could know which one is best. Is that clear?
Yes, thank you.
Okay.
So when we do the comparison, we need to write down all the H0 for each group, for each comparison.
Yeah.
Okay.
Or
we just write the range.
Okay, so remove the H0. You just calculate the table like this, and then you said because 22 is big, out of the range, so they are different. All 3 belong to the range, so they are the same.
Okay.
Okay. For the one, I don't know if someone doesn't know if someone doesn't know the ANOVA singular factors, we would use the Excel, and it gives you exactly the same what we are doing until now. In the table here, you see the p-value. So you have two possibilities. You could compare the F crit with F ratios. So in this case, we reject the H0 and we accept the H1. And we could use the p-values. So here you see the p-value is very, very, very small. Each is small. It's much smaller than 0.001. Normally we take a 0.05, or in this case, it even much smaller than 0.001. So we say that we also can reject the H0 and we accept the H1. Okay.
That means we can conclude using two methods. One is F, and one is using SD, right?
No. So even you use ANOVA, from ANOVA tables, you see that F ratio is bigger than F crit. So you only can conclude the first out conclusion is that there is action of fit. The action of fit for the number of X are different between 3 fit. You only can conclude that. And the next step, in order to see which fit is the best, you have to do this. You have to calculate the SD, and then you calculate the mean difference. And the second step will answer the question, which fit is the best?
Okay, I understand. Thank you.
Only using ANOVA, you can say there's difference in the action of it. But in our case, BNC are the same and A is different with BNC. So you have to do another step to see the final conclusion is BNC are better than A. All right. In the experimental design, for example, you also would like to check different drugs or different metabolites to inhibit the bacteria or to treat some disease, for example. So you have the different extracts from plants. You have different drugs. You could do in parallel 3 or 4 or 5 compounds or 5 drugs as these examples. You analyze the result, and then if you see there's difference in the action of drugs, for example, it's good, right? Because you see the difference. So this is the first conclusions. The next step, in order to know which drug is the best or metabolite is the best, you step this step, okay, to calculate the AD, and then you compare the mean difference. It's happened very often in our experiment when we would like to check multiple compounds, multiple drugs, multiple genes, for example. Okay, so you will use ANOVA if the data follow the normal distributions. Or you could use t-test for each set, 2 sets of data. But it will take more times. Depend on you. Okay, clear for all. Clear? Any
I
more
understand.
questions? Okay, thank you. Any more questions? If not, I will move to another test. Okay. The ANOVA is more complex. You will see another test, but it's less, not difficult, but it's less complex than ANOVA. Okay. Tuyết Mai ơi, Tuyết Mai tắt mic đi. Okay, so we take the difference and we see the significant difference or no significant difference. Okay, next one, we move to the block design. In the ANOVA single factors that we just did before, so we consider that we only check the effect of control factors, which is fit, and we remove the uncontrolled factors like environment factors, for example, the light on pressures or humidities. So we remove all the uncontrolled factors. We focus on control factor and we imagine that there's no actions, there's no effect of uncontrolled factors. But in fact, we may have, right? You can imagine, we do the experiment in different times. We repeat the experiment in different times. And in different, maybe in different room, different months in year. So the environmental factors may be different, right? In summer or in winter, but if we don't control well the rooms, the experimental conditions, we may have some environmental factors which are different. Okay, so we call this, that is ANOVA, but with block design. So normally when you do the experiment when you repeat the experiment, the biological repetitions, you will hope that there's no actions of environment, of uncontrolled factors. If you have the action of uncontrolled factors and you like to study the effect of those parameters at the same time, so at the end, when you have result, you cannot give the conclusion or the interpretations because you have several factors act together, right? We must remove it. We must remove the uncontrolled factors. So by using block designs, it will help you to see if you have actions of uncontrolled factor or not. If the answer is no, you will be very happy. But if the answer is yes, you have to think about the experimental design. Okay. So look at this. The data is the same before. You have 10 observations for A and B and C. Oh, sorry, this one is C. So you have 10 observations. And we have auto show action of block. You have 10 block as well. Okay. Block 1, block 2, 3, 2, 10. And you have mean of block. See, this is the total means. We calculated before. This is the total means. So the additional value here is mean of block. Because you have 10 blocks. So you have new variance, which is variance of blocks. Variance of total, the same. Variance of treatment, the same. You have new parameter is variance of error. Okay. So open the Excel again, and you see if you have action upload in the example.
Cô ơi, em xem lại cái bảng được không ạ?
Bảng đấy
Bảng dữ liệu.
Bảo xóa một dữ liệu nó giống hệt cái dữ liệu khi nãy, bỏ đi hai giá trị cuối của cái MC. Giống hệt dữ liệu cũ. Các bạn một cái này, ở đây có một cái mẹo. Nhìn bảng, nhìn lên slide. So you see in the ANOVA table I showed you before, you have sum of square and degree of freedom of variance treatment and variance of total and variance of error. So what is the relationship here? Do you see any link?
The variance of treatment is equal variance of error plus. Cái tên nhỏ là em không nhớ tên nó là gì.
Tên lớn là variance total.
Thì variance total vào variance treatment cộng với variance error.
Okay, degree of freedom the same. Nhiều bằng đúng không? So you could calculate the sum of square variance of total, sum square variance of errors. Degree of freedom is the same. And to calculate the variance of errors, you do easily. You take the sum of square of VT minus the VT small. Right? So you don't have to use the equation to calculate the variance of error. The sum of square of variance of error. Just do a very simple step. Take the sum square variance total minus sum square variance of treatment. Degree of freedom the same. Okay?
Okay.
Đúng không?
VT chia VE và VB chia VE, mình gọi ở đây mình sẽ có hai cái F ratio đúng không?
Hai cái.
Vì mình có cái block nữa.
Thế thì cái đầu tiên VT chia VE là 112.477.
Ok. VB
VB là 2.3.
F limit.
F limit là của cái VT trên VE là 3.52. Không phải đâu. Đâu, cái F limit là 3.55 chứ.
3.55, đúng rồi. Còn tiếp theo.
Tiếp theo là 2.46.
So conclusion.
Conclusion là là ba cái nhóm này có action khác nhau. They are different.
Gì nữa? Có block không?
The action that they have block.
Có action của block hay không?
Có.
Có à? Thế là accept reject the hypothesis của cái block.
Accept the hypothesis of the block.
Nếu mà accept H0 ở đây là không có action của block và H1 là có action của block. Nếu như accept H0 thì là có hay không có action của block?
Không có
action của block và có action của fit đúng không? Tất cả các bạn khác có làm giống như thế không?
Cô chữa chi tiết hơn một xíu không ạ? Em chưa hiểu lắm.
Ok. Những bạn khác, có bạn nào có kết quả khác hay có kết quả giống của Văn Anh không? Các bạn khác trả lời cho cô nào, để cô có biết đường cô cô giảng ở mức độ nào.
Em cũng chưa hiểu.
Ok.
Còn chưa là em sợ em tính nghĩ lệch.
Ok. Bạn khác?
Cô cho hỏi cái number of blocks là 10 hay là bao nhiêu ạ?
Là 3. Number. Sorry. Ở cái NT là 3, còn number of block là 10.
Dạ vâng ạ.
NT bằng 3.
NT của cái block ấy. Cái N ở trong cái block ấy.
NT lại lấy của block.
Cái hai cái đấy là hai cái N khác nhau đấy. Cô viết ở trên cái slide nó giống nhưng thực ra đó là hai cái N khác nhau.
Tức là cái variant block thì N kia là N của block không?
N của block thì nó chỉ là 3 thôi. Còn cái variant treatment thì N của nó là 10. Đúng không?
Vâng. Em sợ em tính nhầm ở đây.
Có hai cái N khác nhau đấy.
Vâng.
Còn những bạn khác đã tính được chưa nhờ?
Cô ơi, cô chữa variant of block với cô em không biết tính như nào.
Ok.
Em cũng không hiểu ạ.
Ok. Như vậy tất cả những cái variant của show slide show của Excel cho các bạn. BT lớn, VT nhỏ là các em biết tính rồi đúng không? Vậy kết quả các em nhìn thấy ở trên slide. Các bạn có tính tờ VT lớn bằng sum square bằng 3253 không?
Có.
Yes.
Ok. VT nhỏ là bằng 2775 sum square. Có giống không nhỉ?
Có.
Vâng, đúng ạ.
Rồi, hai cái này là mình biết làm rồi đúng không? Bây giờ mình còn mỗi cái V block nữa thôi. So look at the equation of V variant blocks. We need to calculate the upper part of the equations. So it's NT multiplied by MB minus big M square. So how calculate it? NT is 3. Here you see you have 10 blocks. And each block you have 3 level A, level B, level C. So NT here is 3. Okay. Multiply by MB. MB, so you calculate you have 10 value of MB. MB is the mean block. So you have 10 block. It means that you have 10 MB. Okay. And minus big M. Big M is the mean, the total mean. What is the total mean? The value of total mean is 192.4. We calculate before, so it's 192.4. No. Okay. Or you can take 2 or 3 value after the comma is okay. We will set the rule is the 2 or 3 number after the comma. I will say you later in the exam. So normally we take 2. Okay, and square. So you totally you will have 30. You will have 30 values of the upper part of the you will have 30 value of sum of square. Okay, because you have 30 observation. Right? Then you calculate the variance, the sum of square of the variance of log equals sum of all of them. Sorry, I made a mistake here. You have only 10, not 30. You have 10 only, because we take the mean already. So you have only 10. The 10 of sum of square here. You can see in my Excel file. So you have 10 value here. And then you calculate the sum of square of 10 values, which is 256.03. Do you have the same result? This one?
Yes.
Yes?
Yes.
Okay. So you have the 10 sum of square, and then you calculate the sum. And the final result is 256. The degree of freedom of block, and here you have 10 block, so you minus 1. You have degree of freedom is 9. Right? For variance of error, as I said before, you don't need to calculate the variance of error by applying the equations. You just take the variance of totals minus variance of treatment and minus variance of block. So you have variance of error. The degree of freedom of error is the same. Degree of freedom of variance treatment by minus variance of total minus variance treatment and minus variance block. So you have final result is 18. And you have the variance of log and variance of error by divide the sum square for degree of freedom. Then you calculate the F ratios. The first F ratio is the ratio between variance of treatment, this one, divided by variance of error. Second one, the F ratio of variance of log divided by variance of error. So you have the second F ratio. Now you check the timetables. What is it? Oh, sorry, the F table. So the F table, you have the first is 3.55 and the second value is 2.46. Let me check again the table. So for the first F limit, you have the degree of freedom of variance of error is 18. So you find the 18s, and then you cross with the degree of freedom of variance of treatment, which is 2. So you cross between 18 and 2. You have the value is 3.55. Okay. And in the second case, which is F limit of variance of log, so we have the value is 2.46. Okay. So you will compare the F ratio with F limit. And because for the first case, the F ratio is 112, which is bigger than F limit is 3.55. So you reject the H0 and you it means that there is action of block. The second case, you have the F ratio which is 2.3, and the F limit is 2.46, which is bigger than 2.3. So in this case, you accept the H0. If you accept the H0, it means that there is no action of block. Okay, there's no action of block. So is that good or not good if you don't have action of block?
It's good.
It's good. Why?
Because having no action of blocks means that the data isn't affected, isn't significantly affected by uncontrolled factors.
Yeah. So it means that the uncontrolled factor doesn't affect the result. We only see the effect of the control factor, which is fit. That is good. If in this case we reject the H0 and we accept it H1, it means that the action block, and that's not good. So we have to redesign carefully the condition, the environmental condition for the experiment to avoid that. So in this case, very good. We don't have action block and we have action of fit. Okay, and we continue to do the SD to SD and the different means as we did before. So what is the value of SD? We take the root square of 2 multiplied by variance of error and divide by number of repetitions. Okay, so you have SD equal 1.57. 2 SD is 3.14. Okay, and the mean of two groups we calculate before. Yeah, it's the same. So we have the okay, we have to come back before. Yeah. So in this case, the MC is 197. It's not 196 anymore. 197. This one is 7. This one is 7. Okay, so what is the conclusion? 2AD is 3.14. 2SD equal 3.14. What is the conclusion? We don't have action block, and what else?
The effect of fit tree model is different.
Okay, so fit A, fit B, and fit C are different, right? And which one is the best?
Fit B, because it has the highest.
Yeah. So which one? What do you say?
Fit B.
Okay, fit B. Fit B is the best because the average age of fit B is highest. Okay. So you see in this example, we only remove 2 values of fit C, and it changes the conclusions. Number of repetition will affect the result. The more repetitions, the better result you can have. Normally, like this. And in this case, we only remove 2 values of PC, 2 chickens, and it changes the result totally. So in this case, we have the B is the best one, following by C and A. Okay. Clear? We have so the conclusion, there is no action block, and B is the best. A and B and C are different, and B is the best. Okay.
So if we have the action of block do we still need to decide which is the best model, or we use other kind of test?
If we have action block, so in this case you have two parameters at the same time affect the x. So you can conclude, you cannot conclude which fit is the best. We have another test, which is the ANOVA for
Two-way
ANOVA, two factors. So we will analyze two factors at the same time. And is there any interaction between them to give the result? So we will see that on the next lecture. Okay?
Okay.
Is that clear for everyone? Yes? If you have any question
Yes.
more, we will discuss next week.
Cô gửi lại slide để bạn có thể làm lại không ạ?
Được. Này, lát nữa cô sẽ. We stop today.
Cô ơi, cho em hỏi. Tức là cái bài này mình không xét tính min của hai group nữa hả cô?
Có chứ, min của group thì em mới tính được là cái nào là best chứ. Cô đi nhanh chỗ này bởi vì là cái nãy cô đã tính, cái nãy cô đã hướng dẫn các bạn rồi đây này.
À vâng.
Mình sẽ tính chưa? Nhưng các bạn biết rồi nên cô không nói lại nữa.
Vâng ạ.
Gì nữa không? Có hiểu vấn đề không nhỉ?
Rồi ạ.
Okay. We stop today and I see you next Tuesday.
Let's see you next week.
Okay, bye bye.
Good night.
Bye.
Bye bye.